Kubernetes cluster. So previously we have deployed the cluster itself, and now we will use tool like Terraform, Kubernetes manifests, and also Helm to deploy our application into the Kubernetes itself. So last task, Kubernetes cluster. However, there is a much better approach, and yeah, usually just like we do with regular Kubernetes. Just like we do with any other Terraform things like VPC, we can do the same with Kubernetes, means use open source Terraform modules. And yeah, this article, when you type in provision EKS using Terraform, you can use this guide and to deploy your own Kubernetes cluster like really quickly. So you just need to git clone, comment out a couple of things as they are describing here, and run Terraform apply, and everything will be created. Also, you can search for Terraform EKS module. And again, similar to how it's done in a VPC, you can call this module. There are a bunch of different examples, like complete. So this will show you like full options that exist for this Terraform. So what I did is I went with this route, and there is already a cluster with 2 nodes on it. So, but first, let's try our containerized version of our 248 games. There is already a Docker image for it, and we will not spend time Dockerizing an app or building from Docker, but pull it right away and try it running locally, and after that, pull the same public image into Kubernetes. 1 second, let me start my Docker, and it will work again. And just to reiterate, Docker run is a command to create a container from an image. IT means interactive and attached to terminal. This will be needed if we would like to look at the logs. D means in daemon mode or on background, and -p means that we port forward our port 80. This means later when we open it in our terminal, in our browser, we'll see the contents of this container. Very good. Let's stop this for now and try deploying some similar things in our Kubernetes. So Kubernetes can be seen as additional layer of abstraction. So previously we were installing directly into physical servers, then we created virtualization and managed multiple VMs within a single virtual machine. Then cloud happened, where we just managing our own VMs and don't have to manage hosts at all. It is managed for us. And now Kubernetes is built on top of that. It's like another layer of everything. So you can think of it as a, again, universal like abstraction that doesn't allow, that makes you not having to think about underlying infrastructure, especially when you are a developer. You just create a deployment, a pod, or any other Kubernetes API object, and you don't have to think about what's below, what's inside. And that's the main benefit of Kubernetes. And it will be easier for us if we think of it as an abstractions. And if we compare these abstractions with what we already have good familiarity with, in this case is AWS. So the smallest, the simplest abstraction is a pod. We can create it using the kubectl run command, and we can query it using kubectl get pods. So you can think about pods just like you think about VMs in AWS. It's a standalone instance of containerized application. So each pod gets its own IP, and this IP is routable within the Kubernetes cluster. And what we'll do next is create another pod. Nothing prevents us from running, for example, Ubuntu container alongside on the same Kubernetes cluster, and connect to it using like curl or whatever client library we would like. This one will create Ubuntu pod, use Ubuntu image, and it will sleep for 1 hour. Why do we need this sleep? Is because if we just run Ubuntu, it will run the default entry point, which will be like bash. It will exit immediately, and basically the container will finish. And after that, similar to what we did in AWS using SSM or SSH, we can use kubectl to directly access the shell inside this container. For that purpose, there is kubectl exec command. I will install curl, and after that, let me copy this one while it is installing. And our moment of truth. Here it is. Welcome to Nginx. And this is how it was supposed to work. How it was supposed to previous session where we failed. Congratulations to ourselves. But do we really need to launch an Ubuntu container every time we want to test something, even some internal things? No, we can easily delete this. And there is another significantly better option, which I show you now. There is a command called kubectl port forward. And what it does is similar to how we forwarded ports in our Docker machine, in our Docker container, on our laptop locally. We can do the same with Kubernetes. So let me run this. It will start port forwarding. And if we open, this time this will be port 8080, we'll have our Nginx page. Okay, very cool. But actually, you know what? We still need. Oh, this will be next thing. Any questions so far? Yes.
When we run the kubectl port forward command, we can substitute it by creating a service of the type node port. It will have the same effect. Isn't that right?
No, that's not a service type node port, because when we run, let me run port forward again. When we have service type node port, we connect to the IP of the node. But in case of port forward, we connect to a loopback interface, 127.0.0.1. Port forward is like a secure it's a secure tunnel between any network abstraction in Kubernetes. It can be IP address of a pod, it can be deployment, it can be service. It creates a secure tunnel and puts it for us available at 127.0.0.1 and binds a proper appropriate port. This is very useful and very good for debugging when you need to test something and jump inside the Kubernetes networking control plane. Okay, let me delete the pod. And what we do next is run the same pod, but instead of Nginx, we'll use our game. And here we are. But this time, it is running on Kubernetes that's deployed in the cloud, not local. And if we stop port forwarding and refresh the page, it does not work anymore. So that was the pod, the most simple Kubernetes API object. And the next one will be deployment. And you can think about deployment just like you can think about an autoscaling group in Kubernetes, but for pods that are running inside the cluster. And deployment is a set of one or several pods that are managed by this deployment. So for example, we can scale it. And when we set our replica count to, for example, 3, we will notice that we will have 3 pods. And if we delete this pod, for example, deployment will immediately jump in and create a brand new one instead of the previous one to match the desired configuration, the desired number of replicas, which is 3. And but if we check the addresses of our pods, have 3 of them. How do we connect? How do we choose which IP should we have? And the answer is we need something like a load balancer, right? And in Kubernetes, there is a thing called service. And easiest way to create a service in our example is just using kubectl expose. Kubectl expose gain to 48 minus port equals 80. And it will create a service of type cluster IP. This means this IP is available from within the cluster again, but this will still be kind of centralized. So it will redistribute requests to our pods evenly across the cluster. And we can query it the same way we did through our Ubuntu pod. Let's do this one more final time. We can query it by the IP, here it is, or we can query it by DNS name, and DNS name will be the same as a service name, game 248. Here it is. And we can also port forward to the service. And same here, it will be absolutely the same, absolutely identical. But this time, we are connecting to our Kubernetes service. This one was for cluster IP, but there are different options, different types that we have. For example, main ones are, apart from cluster IP, node port, also load balancer, and external name. I will not spend time doing node port because it's kind of complex configuration of bastion host connecting directly to the IP of the node that's running in private subnet. But let's look at load balancer service. I'll delete the previous one and expose it one again and say type equals load balancer. And what it does for us, just as I described in one of our previous lessons, is that Cloud Controller Manager, Load Balancer Controller, interacted with AWS API and created this load balancer for us, which we can open. It's not yet started to resolve, so let me real quick log in into AWS and check that the load balancer healthy. And once it is started to work, probably it will take a minute or two, we will be able to connect to our game even without having to do any export forwards or something like that. And in fact, that's the least viable, very initial way of running real applications. So your clients, your customers never do port forward. They just connect to some endpoint that just works. And let's try one more time. Here it is. Our load balancer returns the same. And the question you might ask, or probably you guys will not ask, because I see that you already have some confidence with Kubernetes. And perhaps you have the answer to this already. Should we learn all these commands? Yeah. And the answer is no. We don't necessarily have to. Instead, we can kind of automate it and even codify it, similar to how we did with Terraform, by using YAML. Have any of you heard about Kubernetes YAML? Yes, Ramdan. Yes.
Yeah, so it's a manifest describing the objects we want to create.
Yes, totally right. So let's, from what we deployed, like manually using our hands, let's generate Kubernetes YAML and recreate everything just by applying the YAML. We have our deployment. Let's query this deployment and have -o YAML. And let's redirect to our file. So let's clean up a little. We don't need significant part of metadata. We don't need this. We don't need these managed fields. We don't need the entire status field. Also, we can have more than one Kubernetes API object inside a single file. So what we'll do next is run kubectl that service gain 248, also in YAML, and append it to our file. Here it is. And same procedure here. We will remove the things that aren't required for us. Here is what we can do. When we can run kubectl delete -f game 248, it will discover these objects that we had in our cluster and delete them. Took it a little while to propagate, and now it's very similar to Terraform apply, in fact. We can apply. we need to remove a couple more things. So probably these this cluster IP section also not needed. Let's try one more time. So when we remove these, okay. So we are safely removing this because if it does not see, it's like in 90% of cases, if it doesn't see a value, it will just either provide a default one or pick a random one. In our case, this will be a random. And same way we did before, we will open our load balancer, the new one, and it will work. Let's also go check our load balancers. That's a new one. Probably couple more minutes. We can test it, for example, using the gig comments. Yeah, we gave us this answer section. And once this is done, we can refresh. And here is our web page. Ta-da! Congratulations. The next question that we have is how we kind of streamline this installation and how we distribute the software using this using this Kubernetes YAML. So in fact, no one applies YAML files directly. And what we can do is group. In fact, we have only one YAML file, but like multiple resources in a single YAML also is not really good thing, honestly. And usually in production cases, people are using either a tool called Helm or tool called Customize. So now what we will do is I'll demonstrate you how to use Helm, how to create a Helm chart, and install this same application, but this time using Helm. So yeah, we've deleted it from here. So then let's move forward and create another folder, call it Helm. And you can think of Helm as a package manager but for Kubernetes. You can build your own package, or you can download and install even your own, even third-party packages that are already available for you. And you don't have to deal with like writing YAML files. You just type Helm install, and it will work perfectly fine. In Helm, it's the best practice to keep one object in one separate file. And what we then can do is run Helm install, the name of our so-called release, how we want to call the thing that we're installing, and the path to our local package, to our local Helm chart. Chart YAML is missing, something that I misconfigured. Yes. For folders, it actually should go like this. The templates should go to the templates folder, and within the folder, the chart for the folder itself, alongside the folder templates, there should be chart YAML. That's the correct structure. We can run Helm ls. Will give us the package that we have and all resources. And all resources that it deploys are kind of grouped together. And that's not the only benefit of Helm. Not only like grouping and deploying, we can also, for example, parameterize it by passing like external variables to it. Or we can use it as a glue to deploy our Kubernetes manifests, our Kubernetes objects into the cluster using Terraform. Let me delete it back. So the main benefit of Terraform, make no mistake, it's not that it can go in multiple clouds, but is that it can go, I prefer to call it vertically. This means it can not only provision your infrastructure, but it can provision your Kubernetes deployment, some Kubernetes object that you need. It can build, it can manage pipelines, it can manage the third parties like CDNs, it can manage monitoring tools. Basically, everything that has an API can be managed with Terraform. And this way, Terraform, using its provider architecture, becomes really powerful universal solution, like a golden hammer. And Kubernetes objects and Helm charts is not an exception here. So let's codify in our Terraform and deploy it in a single Terraform apply. And yes, there is a question.
My question is about Helm. So it uses the kubeconfig file, the default one?
Yes, it uses the same config file that I use for kubectl. And in case of Terraform, there is a couple of settings that we need to pass to configure a separate provider for this, so it picks up the proper Kubernetes file. So we need several data sources, EKS cluster and EKS cluster auth, which means like it will extract authentication data for us that we will pass then to our Kubernetes provider. And here's what these data sources contain. Here's what we have. Here is what we can extract. We can extract the API host. This one, this URL from kubeconfig that I showed to you. We will extract the cluster certificate and also a cluster token. So basically, it's like we are connecting to AWS. Similar way we created our kubeconfig using AWS update kubeconfig command. Same way Terraform doing this through combination of this provider and this data source. And also additional provider for Helm. That's kind of that's the details of implementation. I don't know why exactly they ask us to basically duplicate all these records, both for Kubernetes itself provider and Helm. And combination of these two data sources and two providers allows us to create things like, for example, Helm release resource. And it is equal basically to us running Helm install. And I will call it 248 game Helm, so we can distinguish it. And it will ask us for a chart. And what we need to do next is run Terraform init, initialize the Kubernetes and Helm provider, and Terraform apply. So what it gives us? So it says it will create our Helm release. We press yes. And when we run Helm ls, there is 248 game Helm with our services and deployments. What it gives to us? It gives us, again, this universal golden hammer that we can use everywhere. We don't have to create some crazy bash scripts, some pipelines to deploy additional tools, additional components on top of our Kubernetes cluster or any other type of infrastructure. So you just run Terraform apply and everything ready out of the box. That's very cool feature. I absolutely love it myself. I use it every day on my 9-to-5 job, and I recommend these to everyone. Yeah, so I understand that this one is very high level, and we need to dive into more details. And this demo was quite squeezed and short. But Kubernetes overall is a very complex topic, and it requires a lot. It requires entire separate course, and stay tuned for next announcements. I think we'll have a separate long program for specifically dedicated to Kubernetes. I'm working on it right now, and you all guys are invited there. I will let you know once it's available. Cool. Yeah. Questions? Yes.
Does Helm do reconciliation or no?
Sorry, I did not get this.
So if for instance we delete a service, does Helm recreate that service or no?
No, Helm will not recreate anything unless we install it, run Helm install again. It's not a controller like a deployment. And it's really a good idea and good practice not to touch any resources using kubectl if you are managing them using Helm. Any other questions? Yes.
My question is about node groups. So like it's like an auto-scaling group, so we can create our workers for Kubernetes. What's the instance type? Like, I have two questions. Like the instance type for these workers, how it's like specified, and my second question: how can we create like different kinds of like workers, not necessarily all the same type of instance?
Yeah. Very good question. So let's not talk modules. Let's talk like regular resource. So in EKS node group, there is a property. It doesn't show it in example, but there will be node, or maybe instance type. Yeah, instance types. And basically, it's a list that contains all instance types that you would like in this node group. And you have two approaches. You either provide a list of several instance types that you would like in your node group, or you are creating multiple node groups with different instance types. Both of them works good. Both of them have its own pros and cons. But overall, these two approaches are both reasonable and acceptable. Yes.
Now, my question is about like policies. As my understanding, we can associate multiple policies to the same role. So what happens when like the policies we associated to the role contradict, meaning like a conflict between the two?
The most strict policy will have priority. If one policy allows something that's denied by other policy, deny will take priority. If some policy allows something and other policy does not deny, the allow will be granted. So deny is always higher.
Okay, thank you. I understand.
Okay, so if there is no other question, I wish you have a good rest of your Thursday, and talk to you next week.
Thank you.
Thank
Goodbye.
you. Have a good day.
Bye bye.